Who's that?
What is it? Big sock.
Hi. Ready? Come on.
How you going, guys? Kurtis from Cutting Edge Engineering. Today's job, we're going to be modifying a front strut rod from a 784 cat truck to suit a 785 dump truck. So the front strut is the main suspension component in the front of a dump truck, and it is also the main pivot point for the steering. The 784s are not a dump truck. They are more known as a prime mover or a tractor truck. They generally have a trailer of some nature fitted to them, whether it be a float or a lowboy for transporting machinery on a mine site, or they could even be fitted out with a tipping trailer. The reason why we're modifying this is the customer has a 785 strut rod that has damage to it and the chrome is starting to come apart. So they could potentially send that out for chroming, but that is going to take 4 to 6 weeks in order to get that done, and it is quite expensive. This sort of modification is not common, and that is because the 784 truck series are not common either. Because the 784s have a lot of parts that will fit the 785s, we worked out that these struts are exactly the same, they're just 100mm too long. So we're going to be shortening this one so they can use it on their 785. So ideally we would shorten the top end of the strut where there is no taper, but there are bypass holes that have been drilled in there, and they need to be there in order for the strut to work, and they fall on that 100mm mark, which means we can't do anything on the top of the strut, so we're going to modify the bottom. So before I shorten this, first thing I need to do is drill the holes to the correct depth. These holes only go 70mm deep. When I shorten it 100mm, I'm going to lose that bolt pattern. So rather than lose it, I'm going to pre-drill them down to the correct depth. That way I'm going to save myself a lot of time and setup. So in a perfect world, I would set this up on a horizontal borer, which would make it very quick and easy to drill and tap those holes to depth, but I don't have one of those just yet. And I could set this up in the Zaya, but that would require turning the head around and clocking that in, getting the job set to the right height so I had clearance, and unfortunately I don't have a quill on that, which means I would have to hand feed the bed to drill the holes. That is just way too time consuming, so we're just going to use the mag drill. And because this isn't the first one I've done, I've already got a fixture plate made up. And to drill the holes, I'm going to be using my hole maker Pro 50 magnetic drill. To drill the holes, I'll be using a Goering 22.25mm drill. And this drill's 170mm long, so we're going to have to use the whole length of it. So that's our first hole drilled. That took about 5 minutes, and there's 12 to do. So I've got all those holes drilled to depth. The next thing I need to do is tap them, but because the tap isn't quite long enough, I'm not going to be able to reach the bottom of the hole. So I'm going to tap them past the 100mm point where I need to cut it off, and then that will give me a good amount of thread in order to finish them out once I've removed the 100mm. So to tap the holes, I'm going to be using a 1-inch coarse spiral tap. This tap is secondhand. I have used it quite a bit, and over time they do go a little bit blunt, and I don't want to risk snapping it off down inside one of those holes. I have ordered a brand new one in, but it hasn't arrived just yet. So hopefully that arrives in time for when we need to finish tapping the holes to depth. So that's all of our holes tapped past the 100mm point. Having a horizontal borer would definitely make that a lot easier. That was a hell of a workout. Now we can take it over and set it up in the lathe. for the setup, I am using the steady rest and the tailstock to support this because it is quite heavy and I don't want this to get loose, and I also want to have as maximum rigidity as possible while I'm trying to remove the end of this strut. So now we've got that set up, I can dial in the taper. So to machine the taper, you could definitely use a taper turning attachment. The attachment for this lathe, when I priced it up, was many thousands of dollars, and I don't do enough taper turning to warrant spending that sort of money. The attachment would only give me an extra 80 mil of travel over what my compound can already do. This taper on this strut is actually about 320 mil long, so that would require 2 setups in order to use it. I'm gonna have to do 2 setups using my compound anyway, so I really wouldn't be achieving anything by using a taper turning attachment. And using my dial indicator to set the compound is going to give us a taper that is well within spec for how these are assembled. So that's dialed in. Our compound is reading at about 3.5 degrees. So now I'm going to be machining the majority of that 100 mil off the end of the strut. I'm not going to use a parting blade to start with because parting tools just get smashed when you try to part through an existing bolt hole. So I'm going to use a button insert or a button tool to go in there, get through the bolt holes and make some clearance. Once I've got that clearance, I can then use a parting tool to take the rest of it off. So if I didn't pre-drill the holes to depth, you could use a parting blade to remove that 100 mil of material, but then I wouldn't have the bolt hole location and that would mean a whole nother setup. Right, so I've touched off on the face, zero out the readout, and I've moved up to my 100 mil mark. I've then done a scratch pass around the diameter. That will then be my stop point. I'll then change out to the button tool, and then I can come back 5 mil to give myself plenty of room, and then I can start machining this on. Reach the bottom of the house. I'm just going to make some clearance. Righto guys, so I've gotten through those bolt holes. I was just about to change out to a parting tool when a delivery turned up. It's not the tap I'm waiting on, but it is my heavy duty button tool holders back from nitriding. So I'm going to use that instead. So that's the end off. Now we can finish machining it to length. Right, so we've got the strut machine to length. The next thing I need to do is bore the ID, but I don't want to lose the reference that I set before I even started machining this, and that reference is for the minor diameter of the taper. So what I'm going to do is go back to my 0 points, make a plunge cut in on the face, and that will give me an area to touch off on when I go to cut the taper. So now that that's done, I can set up my boring bar and I can use the digital readout. And the reason I'm not cutting the taper now is I'm going to leave that till last, because the risk of damaging the chrome using a steady is far too high on a component this expensive. So I'll be supporting it with the tailstock and getting rid of the steady rest. And this part of the process is very important because we are machining this to be a very tight tolerance for a blanking plug. And what that blanking plug does is stop all the pressure that gets built up in the strut from escaping. So the first thing I'm going to do is machine the ID to suit the OD of the plug. And while I've got my boring bar set up, I'm going to machine the chamfer in the end. Now with that done, I need to machine a groove for the retaining ring that stops the plug from falling out. And to do that, I'm going to be using my shop modified 16mm button tool. Now with the groove machine, we're going to test fit the plug, and the plug also has a radius machined into it to seat against the retaining ring. And the retaining ring is actually 3 pieces of 5/8 rod that have been bent into the shape of the groove. Not quite, not deep enough. A little bit more. So that seats perfectly. Now what I'm going to do is use my boring bar to chamfer these inside edges. Then I'll use a flapper wheel just to blend in those edges. So that's all the machining on the ID completed. Now we're going to set it up to cut the taper.
Yeah. Ooh, what are these? Just let me get them. No. Sit. Hey.
Lady. Spin. Lady. And high five. Shake. Good boy.
Yum, yum, yum.
No, that's it. Only one.
What else you got?
Righto guys, so we've got that taper machined to within 0.1 of a mil. I am having a little bit of difficulty getting a nice finish on it because the induction hardened layer does come down the taper quite a bit. The carbide insert is sort of just bouncing off it. So I'm going to put in a CBN insert, take off that last 0.1 of a mil, and that'll all clean up nice and true. If you've never heard or used a CBN insert before, they are fantastic for really hard materials. Most CBN inserts only come with one single cutting tip. This brand of insert comes with 4, so it's just like using carbide, except it is designed for extremely hard material, but you can't bulk off with it, you will just smash it apart. If you were looking at a Sandvik or a high-end insert, you could be talking a couple of $100 per insert, where the Union inserts, I think that was $70, and it has done a lot of hard turning. Well worth the investment when you're doing stuff like this. Righto, so that's our taper turned to size. It turned out really well. The length should be 330 mil and it is spot on. So now I'm going to change back to my carbide insert. I need to chamfer the end and then all the turning work is done. Now we're going to get it out of the lathe and get it set up to finish tapping these holes. So before I finish tapping the holes to depth, I am going to go around them and chamfer them with my little pneumatic chamfering tool. This thing is awesome. I got it off eBay a couple of years ago for about $40. I have seen these advertised across multiple platforms with brand names on them for hundreds of dollars. They are all pretty much the same. It does have 2 little triangular carbide inserts, which are still the originals, and it also uses a little bearing on the bottom of the cutter to help guide it around the hole. Probably the only downfall to these is they are extremely noisy and they throw little metal splinters everywhere. But for a job like this, these are perfect. Now that that's done, the last thing we need to do is tap the holes to depth. And thankfully, our new tap arrived just in time. So this tap is UFS, it's made in Italy. This is what my tooling supplier carries. Generally I would go for Goering, but he doesn't hold them in stock. I have used a couple of this brand now and I'm very happy with their performance. So hopefully tapping the holes with a brand new tap this time is going to be much easier. Righto guys, so that's our 12 holes tapped to depth. That was probably the longest process to the whole job. That took about an hour. So this job's completed. If you were to try and buy this from the OEM, you would be looking at about $62,000. Considering we can turn this around the next day for the customer, plus the cost of some consumables, they've saved themselves a lot of money. So this job's pretty urgent. We're gonna get this one back to our customer. Thanks for watching. Right, so, well,
Nice. Good job. Okay, we got the first line out of the way. Excellent. Pew. Kurtis is on a roll.
yeah. Right, ready? And using our dial indicator to set the compound to the right angle is, oh fuck. What was after that? Now we can set it up. So that's all the, right. Don't like that. Hang on. I fucked me up then. But before I do that, oh wait. Shit, I already lost it. Now with that done, I need to machine a groove. Now with that done, I need to
My lord.
Now with that done, I need to, I had too many coffees.
How many?
6 already.
Oh, Jesus.
So this sort of, these struts are exactly this, fuck off train. So hopefully that shows up in time. Right, you ready? Now we're going to set it up to cut the top. You have to film every hole.
Let me do my thing, you do yours. I'm taking a photo, that's on. I'm getting the start and the end. I will do my magic. You just continue to struggle.
Working on it.
Do you want to have a rest?
Fucking between each hole, yeah. Oh,
Do you want me on the other end of it or something?
No. Can't do it like that till you snap taps.
Oh. There has to be an easier way.
There we go.
Fuck. How can you move that? Oh, here we go. Oh my god.
Oh my god. Tap's got blood. Fuck me. Oh, for fuck's sake.
Much easier. No? Look at it, it's coming out way prettier. Yee!
Bentos.
Back of the tool.
We got Bentos. Smells new.
Jesus.
I think it's stuck to my head.
Stuck to your head? Oh, you're bleeding.
Alright.
Yup. Got you right there. Oh yeah, poor little insert. Got obliterated. All the different colours.
Lay it. No. Lay it. Roll over. No. Lay it. You're a good boy.
He looks at the camera like, yes, I'm a good boy. Ah! Okay, where's your treat? Go find it.